In this video, we're going to start developing our fundamental trigonometric identities. So before we get to our first ones, let's go ahead and figure out what is an identity. So an identity is an equation that is true for all values of the variable. So it's an equation that is true for all values of the variable. Now the other type of equation is a conditional equation. And a conditional equation is an equation that is true for some or no values of the variable. An equation that is true for some or no values of the variable. So let's look at an example of a conditional equation first. Let's say we have x squared minus 9 equals 0. And I told you to solve that. And so we would have x squared equals 3, and you take the square root of both sides, and you end up with x equals plus or minus 3. Okay. So this is a conditional. And for an example of a conditional equation, when you solve it, you end up having a finite number, or you have some values that are true, that make the equation true. So in this case, 3 and negative 3 makes this equation true. You can also have the situation where you have no solution. Now an identity is a situation where it's true for all values. So an algebraic identity might be 2x plus 1 equals 2x plus 1. So this would be an identity. Now of course this, you're just saying, well, these two equations are equal, but if you think about it, it doesn't matter what value of x I put in here. I could put in 2, negative 5. Doesn't matter. If I put that value of x in here, it will be true. And so it's true for all values of x. Now, we don't talk about identities much before trigonometry because really there's not a lot of applications for identities in algebraic equations. Because usually when you have an identity in an algebraic equation, it's more of just a, well, yeah, those two are equal. But in trigonometry, they become a little bit more important because it allows us to relate the trig functions to each other. And the thing is that when in circular trigonometry, and we're going to get into this later, but they are what we call periodic. That means they repeat over and over and over again. And so because of this repetitive cycle, there's a lot of identities that help us either evaluate or solve or do other things with these trig functions. So we're going to have to create a toolbox of these trig identities. Okay, so let's go ahead and look at our first set. Put a little line here. And again, we're going to do circular trigonometry. So there's our circle. Here's the y-axis and the x-axis. And here's our triangle. There's theta. Here is x, y, and r. Okay, so the first thing we're going to look at is the following. We know, well, let's write our three main trig functions. The sine of theta is y over r, the cosine of theta is x over r, and the tangent of theta is y over x. Okay, so our first one's going to be this. We know that the cosecant of theta equals r over y. So that was something we did in a previous video. What we're going to do is we're going to look at what is 1 over the cosecant of theta equal to. So that would be 1 over r over y. And if you are dividing by a fraction, you multiply by the reciprocal, which is y over r. Now notice that y over r is the same as this y over r, which is the sine of theta. So here is our first fundamental identity. And that is the sine of theta equals 1 over the cosecant of theta, or, so let's write this down, the sine of theta is 1 over the cosecant of theta, or if I were to take the reciprocal of both sides, the cosecant of theta equals 1 over the sine of theta. And so these are going to be our reciprocal identities, or our first of our reciprocal identities. And that is that the cosecant and the sine are reciprocals of each other. So I'm going to take a nice little side table here, and these are going to be called reciprocal identities. And so our first reciprocal identity is that the cosecant of theta is 1 over the sine of theta. And then the other way we could write that is the sine of theta is 1 over the cosecant of theta, although this is the one we're going to use more often. Okay, let's try another one. We know that the secant of theta is r over x. So if we were to take 1 over the secant of theta, that is 1 over r over x, which is then going to be x over r. And if we come back over here, x over r is the cosine of theta. So this means that the secant of theta is 1 over the cosine of theta, or the cosine of theta is 1 over the secant of theta. All right, let's do one more. And in this case, we're going to take the cotangent of theta, which is x over y. And if we were to go 1 over the cotangent of theta, that's 1 over x over y, which is y over x. And if we go back up here, y over x is the tangent of theta. And so now we know that there's a relationship or an inverse relationship between, not inverse, reciprocal relationship between cotangent and tangent. So let's write that one out. So the cotangent of theta is 1 over the tangent of theta. And the tangent of theta is 1 over the cotangent of theta. A couple more go into this particular part. And the next thing we're going to look at is what happens if we were to take the sine of theta over the cosine of theta. Well, the sine of theta is y over r. The cosine of theta is x over r. And so let's divide those. Now if we're dividing by fractions, we multiply by the reciprocal. So we have y over r times r over x. Notice that the r's cancel out, and so we get y over x. And that one we just had up here. Y over x is just the tangent of theta. So let's go ahead and write that out. The tangent of theta is equal to the sine of theta over the cosine of theta. All right, let's do one more. Let's take the cosine of theta over the sine of theta. The cosine of theta is x over r. The sine of theta is y over r. So when we have x over r times r over y. These cancel out, and so we get x over y. And x over y is the cotangent. So that means the cotangent of theta is the cosine of theta over the sine of theta. All right, so here are the first set of fundamental trigonometric identities. And we have our reciprocals, and we have these two for tangent and cotangent. So this is going to help us. So these are key because it helps us remember what cosecant, secant, and cotangent is. I never remember. So for example, I never remember that secant is r over x. What I remember is that the secant is the inverse of the cosine. So if the cosine is x over r, then the reciprocal of that is r over x. And I do that with the cosecant and cotangent also. Now you do have to remember that tangent is sine over cosine, and well, if tangent is sine over cosine and the cotangent is the reciprocal of the tangent, that means we can take it and flip it and we have cotangent. But we will use these identities in helping us solve problems and other parts of trigonometry, and these are ones that we definitely need to remember.